Hey guys, in this video, we're going to work through two examples using the ratio test and the root test. The first problem is problem 331 in chapter 5.6, and we need to use the root test to determine if this series converges. Okay, so before we start, I want to ask myself, so if the question didn't ask us to use the root test, is there a way for us to determine which is the best test to use? So this is a rule, not like a rule that works all the time, but say, if you look at the denominator, you see 2 to the n. Now, if we look at the root test, we have to take the nth root. So while the nth root of 2 to the n is just 2. So if you see the index n showing up as an exponent, it would be a good idea to use the root test. Now, again, this might not work all the time, but if you're not sure what test to use, a root test is one of the best ways to start. Okay, let's go back to the question. So to do a root test, we have to investigate the nth root of a sub n. Now, a sub n is just n over 2 to the n. Now we have to take the absolute value, but n and 2 to the n are both positive, so the absolute value just disappears. Now we also have to take the nth root of it. The nth root of a sub n is the nth root of n over 2 to the n. Now just using property to simplify, the numerator is nth root of n, the denominator is nth root of 2 to the n. Well, no, the denominator is just 2. Well, the numerator, I want to write it as n to the 1 over n. So now remember that we always have to take n to infinity. So it remains to show what this is as n goes to infinity. Now let's do it right over here. So what is the limit as x goes to infinity, x to the 1 over x? Well, a typical way to do this is to set this equal to y, and then take the logarithm on both sides. Now, using the rule of logarithm, we can pull the exponent in front. And I just want to rewrite it as a fraction. So we get natural log of y is equal to natural log of x over x. Now we have to take x to infinity. Let's do that. The limit as x goes to infinity of natural log of y is this limit. Now we see that the numerator and the denominator both go to infinity as x go to infinity. So this is a perfect time to use L'Hopital's rule. So this is equal to the limit as x goes to infinity, while the derivative of natural log of x is 1 over x, and then over 1, and this is simply 0. Now we know that we can switch the order of the limit and the log. That tells us that natural log of limit as x go to infinity, y is equal to 0. Now we know e to the 0th power is 1. That tells us the limit as x goes to 0, y is equal to 1. So that we can conclude this is equal to 1. So going back to the root test, the limit as n goes to infinity, the nth root of a sub n is equal to the limit as n goes to infinity, which is plug in what we have here, n to the 1 over n divided by 2. We just did that the numerator goes to 1, so this is just 1/2. Now this is clearly less than 1. So the root test tells us that this series converges absolutely. Okay.